Let's finish up conic sections. The last conic section we need to talk about is a hyperbola. So when we talk about hyperbolas, it kind of looks like the equation for an ellipse, but the difference is that the x squared and y squared terms are going to have different signs. So basically we're going to have a minus sign instead of a plus sign in between our two terms. So x minus h squared over a squared minus y minus k squared over b squared equals 1. Whichever one is positive, so in this case the x squared term comes first and it has the plus sign out front, that's going to be the major axis. So this is going to have a horizontal major axis. So that means that the vertices of the two pieces of my hyperbola are going to be across from each other, side by side, horizontal. If the y squared term comes first, and it's the positive one, then we're going to have a vertical major axis. So it looks like a parabola with a parabola being reflected from it, vertically, up and down. Now, there's a new piece to hyperbolas, and hyperbolas have asymptotes. So we've had centers, we've had focus points, which we're still going to have. We've had vertices, which we're still going to have. And now we're adding in our very last new thing, and that's an asymptote. And that's just going to show us where it's going to confine the two pieces of my hyperbola, kind of like that. And the same is true for vertical. So those asymptotes just form an X and confine in those pieces of my hyperbola. So asymptotes have a specific formula. And when we talk about asymptotes, horizontal major axis asymptotes are going to be calculated by y minus k over x minus h equals plus or minus b over a. And then the only thing that changes for a vertical major axis asymptote is it's going to be the same thing on the left, plus or minus a over b. Now in these cases, the a value is always the one that's with the positive squared term, and the b value is always the one that's with the negative squared term. So let's look at an example. So we'll start out simple. Now we know that the y-axis is going to be the major axis. In this case, remember h comma k is always the center. These don't have anything being added or subtracted. So the center for this one is going to be the origin. It's going to be right at 0, 0. The a value here is always the square root of what's here, so that's 5. B is 1. So we need to find our vertices. We need to find out where the bottom and the top of those basically parabolas are. So vertices, they always have the same x coordinate, and then the y coordinate is always going to be h. And this is always going to be k plus or minus a. And in this case, the k is 0. So we're going to have 0 plus 5 is 5, and 0 minus 5 is negative 5. So that's where our vertices are. We also still need to find the distance to our focus points. And we're going to have to, this is still going to be h, and this is going to be k plus or minus c. Now we have to find c, and in this case c is going to be different than it was for an ellipse. To find the c for this one, it's going to be the square root of a squared plus b squared. So a squared for this one is 25. B squared is 1. So this is going to be the square root of 26. Now remember we talked about how it might not be perfect. So if we take the square root of 26, we get about 5.1. So we'll just get this one close. So this is going to be 0, 5.1 and 0, negative 5.1. Now notice how close that is to where my vertices are. So it's just going to be barely beside those or next to those. Now don't forget we've added in a new piece. We have to find the asymptotes. And since we have a vertical major axis, our asymptote is going to be y minus k over x minus h equals plus or minus a over b. Now h and k are both 0, so this is going to be y over x is equal to plus or minus 5 over 1, or just 5. So if we multiply by x over here, the equation is going to be y is equal to plus or minus 5x. Now, it's great to be able to find this equation, and it's not too bad to do it whenever the center is at the origin. But if the center is somewhere else and we have those h and k values to plug in there, it's going to make this a little more difficult. So what I like to do, instead of actually finding the equation of the line, is to count the slope. This will always be the slope, the plus or minus a over b, or the plus or minus b over a. And we can just count that slope from the center. So if we know where HK is, if we know where that center is, then we can count the rise over run from there in the positive direction, the rise over run from there in the negative direction, and then we'll have it. And I'll show you how to do it with this one both ways. So let's sketch this out. We've got all of our pieces there. We know where everything should be. So let's sketch it and see what the shape looks like. So there's my center and my two vertices. So I went up 5 and down 5. Now if I want to go ahead and put the focus points on there, it's just going to be right on the other side of those points. So not very far away at all. And then if I want to find my asymptotes, I can count from the center 5 over 1. So positive 5 over 1, up 5, and right 1. So there's one asymptote. And we can go down and right or up and left as long as we get that other negative sloped line. That's what we're going for. So notice how that slope just makes an So we can always count it from the center like that. We could have graphed both of these lines, y equals 5x and y equals negative 5x, and that would have been fine. It would have given us the same thing. Again, it doesn't matter when the center is at the origin, but it just makes it a lot easier to count the slope if your center is somewhere else. So it's the same concept, just one way is a little easier to sketch than the other. So when we draw our hyperbola, our vertex is there, and then we have those asymptotes to guide us. And that's what our hyperbola looks like. So that's one example. Let's try an example where we don't have the vertex at the center. Here's a new example. Let's find all of the pieces and then sketch this hyperbola. So we know it's a hyperbola because we have an x squared and a y squared term. One is positive and one is negative. Since the y squared term comes first and it's positive, this is going to be our major axis. So it's going to look like our last example did vertically. So remember our center. Be careful with this because remember the x part comes first and then the y part. And the signs of our center is always h, comma, k. And it's the opposite of the sign that is here. So if this is a -6, then this is going to be a +6 in my center. If this is a +5, this is going to be a -5 in my center. Now remember, this is a vertical hyperbola. So all of the x coordinates are going to be the same. So both of the vertices are going to have 6 for the x coordinate. Both of the focus points are going to have 6 for the x coordinate. It's just the y value that's going to change. The only thing that moves is that these are going to go up and down. Nothing goes side to side. So when we find our vertices, remember we're going to use the fact that a is equal to 5. So we need to add 5 and subtract 5 from our center value. So -5 plus 5 gives me 0. -5 minus 5 gives me a -10. So that's where those come from. We have to find C in order to find the focus point. So a squared plus b squared, this time we're going to have the square root of 25 plus 4, which is the square root of 29. Now again, this is just going to be an approximation, so it's going to be about 5.4. So remember we have to add 5.4 and subtract 5.4 from that center. So this is going to be 0.4 and -10.4. So we've got all of those ordered pairs. Let's find our asymptotes. Now I'm going to work this one out both ways, and I'm going to show you why it's easier to count the slope from the center. So let's plug in all the information that we have. Y plus 5 over x minus 6 is equal to plus or minus a is 25. Oh, sorry, a is just 5. And here our b value, remember, is the square root of what's there. So our b value is 2. So 5 over 2 is what we should have there. So if we want to solve this for y, and we want an equation that we can actually graph, we're going to have to cross multiply this and solve it in 2 different ways, because we've got the positive 5/2 and we've got the negative 5/2. So let's cross multiply here. And I'm just going to put that plus or minus with the 5. So if I cross multiply on this side, we're going to have 2y plus 10, because I've got to multiply that 2 by both pieces of that binomial, equals, let's do the plus first, 5x minus 30 and then we're going to have 2y plus 10 equals negative 5x plus 30. So let's solve both of these for y so we can figure out what the equations for our asymptotes are going to be. Now sometimes you will need the equation, but sometimes that won't be the case. So we need to subtract 10 over and then divide everything by 2. So we've got y is equal to 5 halves x minus 20. So that's one equation. And then on this one we have to subtract 10 from both sides. So we're going to have 2y is equal to negative 5x plus 20. And when we divide everything here by 2, we'll have y is equal to negative 5 halves x plus 10. So see how those are the opposite signs for our two slopes. We've got positive 5 halves and negative 5 halves, just like it told me up here, plus or minus 5 halves. And we've got those two equations. Now if we graph these two equations and if we count the slopes, it's going to match. So let's draw this out. So here's our center at 6, negative 5. And here are our vertices at 6, 0, and 6, negative 10. And we can go ahead and put our focus points on there. We're going to go up about 0.4 and down about 0.4 from there. So there are all of those pieces. Now I need my asymptotes. Now from here I can count up 5 and over 2 in both directions. Now I would have had to draw my graph a lot bigger if I were going to graph from here, because this line crosses at positive 10, so we can see that it's pretty much headed in that direction. If I had drawn this all nice and neat and labeled my y-axis up that far, we would see that. And this one has to cross at negative 20, so if I'm looking for a y-intercept here, it's supposed to go through at negative 20, and that would be way down here. So we can see that it follows the same pattern, but we don't have to draw our graphs that large in order to see it. So let's use our vertex and our asymptotes to draw out our actual hyperbola. And that's what it looks like. Now I want to show you one more example, and we're not going to work through it because we did a bunch of these when we talked about an ellipse, and you did really well with the completing the square, those of you that were in class. So if I had a problem that looked like this, and I've got this equation, it does not look like it's in the form that I needed it to be in. So what we have to do is first determine what conic section we're dealing with. This is 16y squared and negative x squared. I've got a positive 16 for a coefficient of my y squared term and a negative 1 for a coefficient of my x squared term. Since one is positive and one is negative, I know I'm dealing with a hyperbola. Now we're going to do the same thing that we did before and complete the square. So I've got my y squared terms together and my x squared terms together. I had to factor out a 16 for my y squared term so that my y squared would be by itself. We didn't have any coefficients there. to factor out a -1 from my x squared terms so that that x squared would have a coefficient of a +1. So we completed the square. Half of 4 is 2, and 2 squared is 4, so we added 4. But remember, we have to multiply by what's out front, so 16 times 4 means we actually added 64. And then for the next one, -2, if we divide that by 2, we get -1, and -1 squared is +1. But we've got to multiply by what we factored out, so -1 times +1, we actually subtracted 1 on that one. So going ahead and factoring out these perfect squares that we made, we've got y plus 2 squared with a coefficient of 16. And we've got x minus 1 squared with a coefficient of -1. Now, this is equal to 1, so I don't want to divide everything by anything, but I want to turn this coefficient into a fraction. So 16 is the same as 1 over 1/16. 1/16 goes into 1/16 times, so it's the same thing. So I'm just bringing this 16 down to the bottom as a fraction. I haven't changed anything. I didn't have to change the 1 on the other side. We just need to rewrite it. We need it to be in that right form, so that's what we did. If we take the square root of this, we can get our a value is 1/4. The square root here, our our b value is 1. Our center is at +1, -2. So we're going to leave that one there, but just know that if it's not in the right form, you can look at it kind of like an ellipse problem and complete that square and get it in the right format. Now, there are a couple of special cases when it comes to hyperbolas. Now, xy equals 25 is actually a very special hyperbola. So anytime you have xy, that product is equal to something, we're going to have that shape. Now, we should know that this is an inverse relation. One value is going to be increasing as the other one decreases. Now, the asymptotes here are always going to be the x-axis and the y-axis, or the y-axis and the x-axis, the way I have it written. And our vertices, if we take the square root of 25, we get 5. So one pair is going to be +5 and +5. The other pair is going to be the negative version of that. So we've got -5, -5, and -5. So when we sketch this out, the asymptotes are the x and y axis. Our vertices are at +5, +5, and -5, -5. And these are just going to be really wide hyperbolas. And instead of being vertical, this one's a little sad looking, but instead of being vertical, they're diagonal from each other.